तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Hello and greetings. In our ongoing exploration of databases, we had started out exploring the default or the standard for database querying, namely the structured query language or SQL. So let us continue with SQL in this session today and look at some of the more advanced aspects and what kinds of queries that you can express within simple SQL statements. So before we begin, let us summarize what we have studied until now in terms of SQL. Now we looked into an introduction to the SQL standard and what are the building blocks of SQL, namely tables, attributes and values, which are tables, rows and columns, and we also saw how to create schema in SQL and what is meant by a schema and how do we create tables and what kinds of column descriptions can we give when we create tables and what kinds of constraints can we specify when creating tables and so on. We also saw how to specify entity constraints, specifying what is the primary key and what are the secondary keys in a relation or a table. We also saw how to specify constraints like something should not be null or something should have a default value, and we also saw how to specify foreign key constraints so that referential integrity is maintained. And we also started by looking into the different forms of the select operation, which is perhaps the most frequently used SQL operation for retrieving tuples from the database. So the most generic form of select operation is the select from where clause, where you say select attribute list and say from table list where a given condition holds true. We also saw how we can disambiguate attribute names, especially when we are using multiple tables and 2 or more tables have attributes with the same name. One simple way of disambiguating attribute names is to prepend the name of the table before the attribute name. So we saw something like instead of saying name, we say employee.name or department.name and so on. So on the other hand, we can also use aliasing for disambiguating names, mainly because when table names are also the same, when we saw the example of a join between employee and employee tables. So we basically use the notion of aliasing, where you say use the term or use the table employee and call it as some other name, like say E or boss or whatever. Then we also saw how we can select from multiple tables, the Cartesian product of multiple tables, or and what happens when we omit the where clause and so on. And we also saw the different kinds of set operations on tables. By default in SQL, and very unlike relational algebra, in SQL tables are treated as multisets or bags. That means it can tolerate or it is valid to have different tuples of the same having the same data in a SQL table, which is not valid in or which is not valid by default in relational algebra. So we can make a table into a set by using the keyword called distinct. So when we say select distinct some query, a query is returned with all duplicates removed from the query. We also saw how to perform set operations on tables, and the sets by default, these operations by default assume that tables are sets, like union, intersection, and except for set difference. If we have to specify that the tables are not sets, but instead they are bags, we have to we have to use the qualifier called all. So we say union all whatever. So we say employee union all department and so on, or employee union all managers and so on. And we also saw how to compare substrings using the percentage symbol or the underscore symbol which matches a single character. And we also saw some arithmetic operators like addition, subtraction, multiplication and so on, which need not just be used within the where clause, but they can also be used right after the select clause itself. So let us move on further today, and in today's talk I will be using two example tables in order to illustrate several features of SQL. So let us look into these tables once again. The first table that we are going to be considering is the employee table. So the employee table contains employee number, which is the second field shown in the slide here, as the primary key. It also has a secondary key called PAN number of the employee, which obviously has to be unique and non-null. And employee is given a name, gender, date of birth, address, salary, and reports to, which is a foreign key. That is, reports to contains another employee number, which refers to the manager to which this particular employee reports to. If reports to is null, then it means that this employee is the head of the company, or that is he does not report to any other employee. Then there is the department number or the D number, which shows where the employee works in. The second table that we are going to be considering today for our examples is the department table. The department table, as shown in the slide here, is indexed by or uses as primary key the field called department number or D number, which is the same as the D number used in the employee relation. That means the same domain. Department also has a name, address, and head, which is again a foreign key, which points to the employee number of the employee who heads a particular department. So here are the specific declarations, which says primary key is D number, and head is a foreign key which references employee number in the employee table. So we had started out with looking at arithmetic operators. So let us continue from that point on, and we had seen how you can use plus, minus, star, and slash as to perform arithmetic operations, namely addition, subtraction, multiplication, and division. Similarly, you can use the operator called or you can use the keyword called between to check for a range, that is to check whether a given parameter lies within a given range. The slide here shows an example which is of the form select star from employee where salary between 3 lakh and 4 lakh. Therefore, this query returns all employee records. Select star in this case. Note that the star here is not the multiplication operator, but star here refers to the entire tuple in this when star occurs by itself. Therefore, this query selects the entire set of tuples or the entire set of columns for all tuples where the salary field or the salary attribute is between 3 lakhs and 4 lakhs. It is also possible to sort the output of a given query using one or more parameters. The sorting is achieved by a new construct called order by. This construct is shown in this slide here. This slide shows another small query which says select star from employee where salary is greater than 3 lakhs and order by name and employee number. Therefore, this query returns the same result as the previous query, that is the set of all tuples, the complete tuples for all employees well, not exactly the same, of course, for all employees whose salary is greater than 3 lakh but not necessarily less than 4 lakhs. And the output here is ordered first by name and next by employee number. So that means that it is first ordered, the records are first ordered by name, and wherever there is a tie, that is 2 or more employees having the same name, it then orders those tuples using employee number as the ordering attribute. We now come to the next aspect of SQL querying, perhaps what gives it compositionality, so to say, that is by which you can compose queries, bigger queries from smaller queries. This is what is called as the nested query. Note that just like in relational algebra, the output of an SQL statement is a table, especially the select statement. The output of a select statement is a table, and the input is also a table. It can be multiple tables which are treated as a Cartesian product in which case. Therefore, the output of a particular query can be used as part of another query to perform further searches. So the slide here shows such an example where a query has 2 different parts in it. For the sake of convenience, they are shown in 2 different colors, white and yellow. There is an outer query, so called outer query, which says select name from department, that is select the names of departments where d number in. So in is a new keyword that we are also introducing here, which essentially stands for set membership. That is where the d number or the department number belongs to the set of all tuples that are returned by the query which is shown in yellow. That is where d number in the query called select d number from employee where salary is greater than 3 lakhs. So let us analyze this query. What does this query do? Firstly, take a look at the inner query. The inner query says select department numbers of all employees whose salaries is greater than 3 lakhs, and the outer query is saying select the names of those departments which are returned by the inner query. So essentially this query is asking the database, show me all departments which pays greater than 3 lakhs as a salary. So the highlighted query, the yellow part of the query here is called the nested query, and the non-highlighted query is called the outer query in this case. So let us continue with nested queries, and note that a nested query contains 2 different queries, and the inner query or the nested query in this case returns a complete relation or returns a complete table. For all practical purposes, we can consider the table as sets or bags comprising of different tuples. And the in clause that we used in the previous slide performed exactly that, did exactly that. That is, it considered the table that is returned by the inner query as a set, and essentially performed a test for set membership, that is whether the d number specified in the outer query belongs to the set that is run in the inner query. Similarly, one can do a check for a particular attribute against all elements in a set using the keyword called all. This is shown in the slide here. The outer query says select name from employee where salary is greater than, and then the inner query begins. This is shown in the slide here. So the inner query here says select salary from employee where supervisor equal to 007. Okay. So let us try to analyze this query step by step. First, take the nested query or the inner query here. It says select salary from employee, that is, give me the salaries of all employees where, well, it should actually be reports to. There's a small bug in this slide where reports to equal to 007. That is, give me the salaries of all employees who report to 007. Okay. So, we just want to know what does this employee number 007 or agent 007 pays all of his subordinates, and then the outer query says select name from employee, that is give me the names of all employees where salary greater than all of this inner query, that is whose salary is greater than all of the salary that is paid by 007, that is it is greater than the maximum salary that is paid by 007. So, it returns the names of all employees whose salaries are more than the salaries of all those who report to 007. Now, what happens to disambiguation of attribute names when we are considering nested queries? So, this slide here shows such an example. Firstly, the rule which says that any unqualified attribute name in a nested query applies to the innermost block of the query. So, what does that mean? Have a look at the query here. There are again two levels to this query. The outer query says select e.name, and then I say from employee as E, that is I am using I'm aliasing employee table as E, where E dot employee number in, and then the inner query begins, which says selects reports to from employee where E dot name. Note that I am using the alias called E inside the inner query as well, while the alias is actually defined in the outer query, and then I say E dot name equal to name. Okay. So, what does this query do actually? So, if you notice closely, the outer query as well as the inner query works on the same table called employee. The outer query calls itself as E, and the inner query does not change the name of the table, it is still called employee. Therefore, in the inner query when I say select reports to, that is give me the set of all employee IDs of the bosses of all employees where the name of the employee is the same as the name of the boss, that is E dot name here would be the boss here, because I am looking for E dot employee number to occur within this set of all employee numbers who are bosses. Okay. So, the query essentially returns all employee names who have the same name as their boss. So, let us look at a few more definitions pertaining to nested queries. The kind of query which we just saw now, that is where a particular alias is defined in an outer query and then used inside an inner query, such kinds of queries are called correlated nested queries. That is there is a greater correlation other than the fact that an inner query or a nested query occurs within a condition. There is a greater correlation between these two queries. Now, how do we understand or how do we analyze the behavior of a nested query? Now, to understand how a nested query begins, it should be noted that, or it is sufficient if you just note that every select query is performed or every select condition is performed exactly once on each tuple that is specified in the table, for the table specified in the query. Therefore, let us have a look at the previous slide once again. In the previous slide, for the time being, consider just the outer query. Assume that there is just one select statement which is the outer query. Okay. So, this statement says select some attribute, that is E dot name, from the set of all tuples in employee where some condition, that is E dot employee number in whatever. Okay. So, let us not worry about what the condition is, let us just assume that there is some condition called C. Now, this condition, that is in this case the nested query and the set membership function, that is E dot employee number in that nested query, this whole condition is checked once for every tuple that forms the employee record, that is that forms the employee table. So, for every employee this particular condition is checked, that is for every employee we are checking whether his employee number occurs in the set of all employee IDs of people who have the same name as one of their subordinates. Okay. So in that way, as long as we remember this fact that select query or the select condition is checked once for each tuple, it's easy to understand nested queries in some kind of a recursive fashion. That is, you have to understand this for each level in a given nested query. So continuing further with next nested queries, we can use the term or the keyword called exists, or of course not exists, to check whether the output of a given nested query is empty or not. So if the output is not empty, then exists returns true, that is there exists some results from this query, and if the output is empty, then exists returns false, or not exists returns true. So there is an example given in this slide regarding this. It just says select d dot head where from department as D, of course, that is alias department as D, where not exists, okay, where the following condition does not exist. What is the following condition? Which is the inner query. Select employee number from employee where reports to equal to D dot employee number. Okay. So that means essentially I am looking at the head of all departments, that is I am looking at d dot head. Okay. So the employee numbers of the heads of all departments where this does not exist. What is this? Select employee number from employee where reports to equal to this should actually there is again another bug here. This should actually be employee dot employee number, that is or d dot head rather. So where reports to equal to this head. That means give me the set of all heads of departments who do not have anything or who do not have anyone working under them, because this condition should not exist is what we are checking for. We can also specify explicit sets. Until now we have been looking at implicitly defined sets. We have looked at set membership in the form of in condition, we have looked at set comparison in the form of all condition, and we have also checked for empty sets using the exists condition. But all of these sets were actually specified in the form of a query, that is the nested query. We can actually specify sets in a more explicit fashion using just parentheses, that is we just parenthesize and enumerate all elements of the set explicitly. The slide here shows one such example which says select name from employee where reports to in 007, 008 and 009. Therefore what it says is that give me the names of all employees who report to either 007, 008 or 009, or that is whether the reports to field or the reports to attribute holds one of these values in this. One can check for null values in an SQL table using an SQL command called null, or a SQL keyword called null, capital NULL, and you can also you can also check for whether something is null or is not null. So remember what constitutes a null value for a particular attribute. A null value is a value which is not applicable, or an attribute which has no value or no semantic value associated with for a particular tuple. This is different from saying that the value of the attribute is 0 or unknown. Okay. So the example here shows a query which says select e dot name, e dot salary from employee as E. Okay. So that is select the names and salaries of employees where something exists. Okay. What is that exists, or that is where the following set is not null. What is the set which should not be null? The set which says select employee number from employee where E dot reports to equal to employee number and reports to is null. Okay. So let us analyze the interior query or the inner query again. Okay. It says select or give me the set of all employee numbers from the employee table where E dot reports to, that is the employee from the outer query is a subordinate of me, that is the employee in the inner query, and reports to is null, that is I do not report to anybody else. Okay. So, essentially the query returns the names and salaries of all people who report directly to the head of the company. That is, this is the name and salary of all people where the following condition exists. The following condition here is the set of all their bosses who also happens to be the head of the company, that is who does not have any other supervisor himself or herself. Okay. So, note that here the use of the condition is null, that is whether reports to is null. This is different from saying reports to is 000. Suppose 000 is a valid employee number. This is different from null, that it means that this employee has a boss, but in this case this is looking for the fact where this employee does not have a boss or does not have anyone to report to. Just like we have been using aliasing for renaming table names, the as keyword or the as clause can be used to rename attribute names as well. So, the slide here shows such an example. It says select name as employee underscore name from employee. So, what does it do? It simply selects the set of all employee attributes from this table. However, while returning it, when the table is returned, the name of this attribute is changed from name to employee underscore name. Now, this in turn can may probably be as part of a larger query where this would matter, or even if it is just printed out on the output, the name of the attribute would have changed from name to employee name or employee underscore name. Note that when a select query is run over multiple tables, that is the from clause contains multiple tables, select name comma salary from employee comma department, by default it assumes that we are having a Cartesian product between the tables that are specified. Therefore, if we have to compute a join between employee and department, for example, we have to explicitly identify which is the attribute on which has to be compared. Therefore, in a simple select operation, let us say we have to join, we have to compute a join between employee and department. We would say something like select star from employee comma department where employee dot d number DNO. Remember what the employee record looked like. The employee record had one of the fields as D number or the department number of the employee where he is working in. So, where employee dot D number equal to department dot D number. Okay. So, we have to explicitly equate these two attributes to perform a join, otherwise it is construed as a Cartesian join between employee and department. On the other hand, we can specify a join that is rather than a Cartesian product using the keyword called join. The slide here shows such an example. The slide shows a query which says select name comma address from employee join department. Now, when we just say join without any further qualifiers, there is still not enough information to identify which attributes to use for join condition. What is the theta or what is the join condition here? Therefore, we specify that condition explicitly. So, we say as shown in the slide here, select name comma address from employee join department on DNO equal to D number. Note that DNO was is an attribute of employee and D number is an attribute of department. So, so this is specifying an equi-join condition, that is it is equating D number DNO to D number, and of course there is a where condition which says department dot name equal to research. Therefore, it is computing the join between employee and department and selecting only those tuples where department name is called research, and then printing the set of all names and addresses of employees who work in this department. It is also possible to specify natural join directly without having to specify the equality condition. Note that in a natural join, if we have two tables, at least one of the attribute names should be the same or should be common between the two tables. So, a natural join which in relational algebra was depicted by the star operator just performs an equijoin between two relations where the set of all where it has some subset of attributes having the same name. Okay. So, the same condition also holds true in SQL, that is, if you are performing a natural join, you have to have at least one attribute name which is the same. You can always change the name of a table and its attributes names using the as clause, which we have already seen. Okay. So, a natural join may be specified using the natural join construct. It automatically finds attributes having the same names for performing the join, and of course relations can be renamed, relations as well as attribute names can be renamed in order to accommodate natural join. So, there is a there is a specific example here which says select employee.name comma department.name from employee natural join department. In our specific example though, the only attribute name which was common between these two was the name clause itself. Therefore, for our particular example schemas that we had taken, this query may not make sense, but the syntax of the query is illustrated. The main idea behind the example is to illustrate the syntax of the query. We just say select employee.name comma department.name from a natural join between employee and department, that is, identify all attributes which are which have common names between employee and department, and compute a natural join and then project the set of required set of attributes from them. Similarly, other kinds of joins which we saw in the session on relational algebra can also be specified using the appropriate keywords in SQL. Just like you have natural joins, you can also specify left outer join, right outer join and full outer join as part of any SQL statement. We next come to the notion of aggregate functions in SQL. Until now we have been working on generating a set of tuples or the set of all tuples that match a particular criteria. Sometimes we may need aggregate properties of a query rather than the set of all query results. So, there are a number of aggregate functions in SQL. Some of them are shown here. There, for example, count, which counts the number of tuples in the query result; sum, which computes the sum of the set of all values in the query result, in which case the query result should return a single numeric attribute; average, which computes the average of all values in the query result. Again, the query should return numeric attributes; max and min, which computes the maximum and minimum values of all the query results. And of course, max and min will work if the query results are numeric or they are ordinal, which basically means that they have some kind of total ordering that is specified among them. For example, date. Date has a total ordering. You can always compare two or more dates. So, you can the query can result the maximum and minimum among dates, and of course, char. You can always compare characters using their ASCII equivalent. So, the maximum and minimum can be written. Here is a small example query shown in this slide, which just says select count of salary, min of salary, max of salary, sum of salary and average of salary from employee, which is obvious. It just counts the number of salary elements. As you can see, I could have as well said count star. It does not make any difference because it just counts the number of tuples in the relation, and min of salary, min of the salary field, max of the salary salary attribute, sum and average of all the salaries. Since aggregate functions return a single value and not a table, they can actually used as part of they can actually be used as part of a logical operator within a where clause. Until now, when we have been talking about nested queries, we have been treating the nested query as a set, and we have only been applying set theoretic operators like in and all and exists and not exists and so on. Okay. But once I use a aggregation function and reduce our query result to a single value, I might as well use it as part of a logical operator. The example in this slide shows such a case, which says the outer query says select e dot name from employee as E, where the inner query says select count star, that is select the count of all the set of all tuples that are returned by this query. And what is the query? From department as D, where department dot head equal to E dot employee number, that is it is selecting the set of all employee numbers who heads departments, okay, and counting the set of all counting the set of all such queries. That is, it is for each employee that is searched in the outer query, it is seeing it is first searching the set of all departments that the employee heads and returning their count, and this count is compared with 2 here, that is greater than or equal to 2. Therefore, the semantics of this query is return the names. Note that we are finally returning e dot name, okay. Return the names of all employees who head 2 or more departments. In some cases, when we are talking about aggregate functions, it is not really desirable to apply the aggregate function to the set of all query results, set of all tuples that have been returned by the query. It may be more desirable to apply this the query or the aggregation functions to different subgroups of the query results. Now you can specify such subgroups using what is called as the group by clause. The group by clause is shown in this query here in this slide. The slide shows a small example. Select D number DNO comma count star comma average salary from employee group by D number. What it does is, for each department, that is it first checks the or it first scans the set of all tuples in the employee table, and then groups this set of tuples according to D number or DNO, okay. So for each department that are contained in the employee table, count the number of people working in it, that is because we are counting the set of all employee records which have this DNO, okay. So count the number of people working in this department, and return also count the average salary of the people who are working in this department. But note that the group by function is computed after computing the results of a query. That is, the query first scans the set of all employee records as in the previous example, and then groups those records or groups those tuples based on DNO, and then performs the select operation. However, if we want to select certain tuples based on some aggregate property, not an individual property, note the important difference here. Suppose we want to select a set of tuples from a table based on some aggregate property, we can use a different keyword called having clause, okay. The slide here shows such an example. It says select DNO, that is select the department number, count and average salary from employee, group by D number, that is it is the same query as earlier, that is for each department return me the count and number of people working in it and average of salary, having count greater than 20. That is, there is a further constraint here. For all departments having more than 20 people working, show me the department number, the number of people that are working there, and their average salaries. Note the difference between having and where clause. You might be wondering, we could have just used the where clause, select from where. Where actually specifies a particular condition, and having is also specifying a particular condition. Now what is the difference between having and where? Having versus where. where conditions apply to individual tuples independently. That is, the where condition where I say something like salary greater than 3 lakhs is applied to each tuple independently. However, the having condition applies to groups of tuples, it is an aggregate property, that is having count greater than 20, that is the number of tuples is greater than 20, or the average of salary is greater than something else, and so on. So, having is specifies a condition that applies to a group of tuples, whereas where specifies conditions that apply only to individual tuples. So, let us look back at select now. How does select look like after going through all these different different variants of selects? Now, once we look back, looking at all these different variants, we see that the select condition has the following construct. Select attribute and or function list. I can also give a function, remember, I can always say select 10 times 10 star salary, that is what happens if my salary increases by 10 times, and so on. Okay. So, select attribute list or function list from table list, and the rest are all optional. The where condition is an option. If you do not specify where, then every tuple is checked. Okay. Group by grouping attributes. How should the tuples or how should the output be grouped? Having group condition, that is some kind of aggregate properties that we can check, and then finally order by, which is the sorting condition for the output. We now move into other operations within SQL. Select obviously is the most widely used operation, and hence the most detailed in terms of its syntax, but we still need operations for inserting or adding data into tables, and modifying tables, deleting data from tables, and so on. By modifying tables here I mean modifying data in tables, not modifying the structure of tables, which can be done using the alter table command. Okay. So, insertion of data into tables can be performed using the insert command. The insert command is shown in this slide. Just like we have select from, we have insert into. So, we say insert into employee values, and I give the entire record for the employee within parentheses. So, I am inserting a complete record where the first 1002 stands for the PAN number, the second 002 stands for employee ID, the third field Bharat Kumar stands for the name, then M stands for the gender, 9/5/1973 stands for date of birth, and so on. Okay. So, you can specify the entire tuple inline into the query itself, and corresponding fields and the corresponding attributes are matched. So, inserts an entire employee record with corresponding values. On the other hand, I can insert or I can specify only a partial set of attributes within the tuple. So, this slide shows such an example, which says select into employee, or rather insert into employee, name, address and D number, values Arun K, Yeshwantpur, and 5. Therefore, it returns or it inserts only those fields or only those attributes called name, address, and department number, or DNO. What happens to the other attributes? The other attributes will either get a null value or the default value if a default is specified. Therefore, you can see that there is an implicit constraint in this select operation, that is, I cannot leave out, when I am inserting a tuple, I cannot leave out any attribute name which contains a non-null constraint, not null constraint, and does not have a default value. If it does not have a default value and it is not allowed to be null, then I have to specify a value during insertion, or else insertion is going to fail. An insert or insertion of more than one tuples within to a table can also be performed using a select operator, select operation. Note that select actually returns a table. Now, if I return and table is nothing but a set of tuples. Now, if a select operation returns a set of tuples and these tuples are in a format that are ready to be inserted into another table, I can directly specify the select command within the insert command. This is shown in this example here. First I just create a table called EMD, which contains just 3 attributes: employee, manager and DNO, that is the department. Then I give an insert command from the employee and department table using the following syntax. I just say insert into EMD, that is insert into the new table name, and what should I insert? The output of the following select operation. Then I just give the select command, that is select e dot employee number as employee, e dot reports to as manager, and d dot d number as DNO, and then from employee as E, join department, and so on. So basically I am getting a set of employee number, manager number and department number, which is what is going into the new table. So what are the properties of the insert command? Let us summarize the insert command once again. So insert can insert tuples that are specified as part of the command, and all attributes which are not null and do not have a default value have to be specified as part of the insert statement. And what happens if I give the same insert statement twice, that is the same insert statement with the same set of data elements, and it is actually performed twice? It does not, insert does not do any checks, that is remember that tables are treated as multisets rather than sets. Therefore insert just goes and inserts the tuple again, that is a second occurrence of the same tuple. This is done as long as the second insertion does not violate any unique constructs. That is if I give a set of data values in the first tuple and give the same set of data values in the second tuple, and one of the attributes has to be unique, then the condition, then the constraint fails, and in turn insert also fails. So as long as the unique construct is not violated, insert will just insert multiple tuples into the table. Insert also fails if referential integrity is violated, that is if your DBMS supports it, of course. That is if I try to insert an employee number as manager which refers to a manager entity which does not exist, referential integrity fails. Multiple tuples can be inserted within a single insert command, first of course by using the select statement, or by just giving multiple tuples one after the other separated by commas, and each tuple is enclosed within parentheses. Deletion of tuples. How do we delete tuples from a table? Deletion of tuples is very similar to the select statement and has the same structure, which is of the form delete from where. It says delete from employee where some condition, that is employee number equal to 007, the first one, which just deletes one tuple. Note that employee number is the primary key, therefore it is unique, and therefore it just deletes one tuple. On the other hand, the second tuple says delete from employee where department number in the set of all departments that are headed by 007. So it can delete possibly more than one tuple in this statement. On the other hand, if I remove the condition and I just say delete from employee, it deletes all tuples. Note that deleting all tuples is different from dropping the table. Here deleting all tuples corresponds to truncating the table, that is the table exists but it has no tuples in it, whereas if I drop the table itself does not exist in the database. Updation of tuples. How do we modify tuples? You can update tuples by using the update operation, and the update operation also has a very simple syntax which is of the form update set where, that is update employee as shown in this example here. So update employee, set whatever updation I need to make, that is set salary equal to salary times 1.1 where reports to equal to 007. Therefore what I am doing here is that for all people working under 007, I am updating their salary by, or I am increasing their salary by 10%. I am giving them a 10% raise by this update statement here. We now come to the last leg of this session, where we take up the notion of views or virtual tables. This is again an important concept in when designing large databases. View, as you can typically or intuitively understand, is one particular view of the database, that is one particular projection of the database which is suitable for certain kinds of work. That is, let us say a HR manager needs to know only the employee, that is the HR related details of an employee. He does not need to know the technical details of an employee or the project related details of an employee. Therefore, we have basically created a view of the employee record for the HR manager, which is different from the view created for, let us say, the project manager. So a table or a view is also called a virtual table. This is a table that is derived from other tables. In contrast, a table that exists in the database is called a base table. So a view can be derived from either other base tables or other views. Views need not be stored. It is not that they are not stored, but views need not be stored in the database. That is, the data contained in the views need not be stored in the database, but they may be they are typically stored as queries and not as tables. And update operations for views are limited. This is as a result of storing them as queries, but querying is not. You can query, but updation is limited in terms of views. So views can be created in SQL using the create view command. This is again a pretty simple construct which is shown in the slide here, which says create view and EMD, which is the name of the view, and there are three fields: EMPL, MGR, and department. So this is the structure of the view, that is the name and the attribute list, and this view is created as this query. That is, whenever I need to compute this view, I just need to run this or execute this query. This query is going to return a table which will populate the data that is required by this view. What are some of the properties of views? Because a view is stored as a query, a view is always up to date. I do not need to modify a view when I modify some data elements in my table, because there is no data element that is stored in a view. Hence, characterization of a view is not done during view definition time. That is, when I define a view, I just leave it like this. When I define a view like this, it is just left like that. It is not characterized, it is not computed, but this computation is done during the time of query. That is, when I give a query on a view, this characterization is done. Views can be deleted using the drop view command, just like we can delete a table. The efficient implementation of a view is a pretty tricky problem, and we shall be addressing this view maintenance as a separate session in itself, because how do we efficiently maintain a view and execute queries over it? So that brings us to the end of this session. So let us briefly summarize or look at the titles of all the different topics that we have studied. We looked into the SQL2 standards, tables, attributes, values, and constraints, entity constraints, foreign key constraints, and so on. We looked at several different kinds of select operations, select from where, and disambiguation, aliasing, selecting from multiple tables, set operations, multi-set operations, substring operations, arithmetic operations, existence checks and null checks, nested queries, and aliasing and scope in nested queries, and group by constructs and having constructs, and so on. And then we also looked at SQL statements for insertion, deletion, and updation of tuples from database. Finally, we looked at the notion of views or virtual tables, or rather I should say that we have just scratched the surface of views or virtual tables, and saw how we can specify a view in SQL using the create view command. So that brings us to the end of this session. Thank you.